3.3.3.3. For example, these two interfaces run OSPF. They also generate detailed information about these interfaces. After generating, the way is the same as R3. They are flapping each other. Then all learn the local. Count yourself. That is to say, all devices in the network will generate detailed content and will be synchronized with other devices. Then after synchronization is complete, it will bring a phenomenon. That is, each device has all the information about R1, R2, and R3. If R1, this generates a message. R1 passed to R2. R2 passed to R3. R3 has a message. Then R3 passes to R2. R2 passed to R1. If it is R2, here is a message. R2 passes to R1. Will also be passed to R3. So eventually it leads to a phenomenon. Is now in the entire network environment. All devices can actually get information about other devices. This has nothing to do with broadcasting. The broadcast we are talking about is more inclined to refer to a broadcast domain. At this stage we have not talked about VLAN. Everyone can understand that. They are on the same network segment. For example, there is now a switch. Multiple devices connected to it. They all belong to the 192.168.1.0 network segment. The switch now wants to send a broadcast data. Assuming a 24-bit mask. It can send 192.168.1.255. It's called broadcasting. In fact, broadcasting is also a flapping action performed by the switch. But the second and third floors are slightly different. You will often hear the word flapping in the future. The term is used in descriptions of different environments. Its meaning is slightly different. We'll talk about swapping in the next lesson. Also mentioned flapping. In fact, there is not much difference in essence. All except the interface that receives the data. Send another interface. This is called flapping. In fact, you can understand it as copying and sending a copy. But it's not broadcasting. All three devices can eventually get the information of all other devices. That is, R2 generates its own. R1 also generates its own. Eventually they all get information about every other device. Sync now. So now all devices in the network will synchronize the same information. That is, everyone maintains the same information. The device is not in a hurry to calculate the route. When all the information is obtained, it probably knows that there are R1, R2, and R3 in the network now. No fourth device. Then look at what they post. Because there are many parameters in this detailed content, the device can draw a map based on this information. So each device will first synchronize all the information later. They go to calculate. It's like we learn. You have to listen to the teacher to finish all the bits and pieces of knowledge first. And then summarize. Distance vector routing protocols are relatively inferior to link state protocols. But EIGRP is an advanced distance vector routing protocol. So it is actually divided into two steps. For equipment, the first step is to synchronize link state information. Then go to calculate the route. This synchronization algorithm is called the SPF algorithm. Let's talk about the characteristics of the distance vector routing protocol. You will learn about other link state protocols later. But they have the same characteristics. It passes the details of the device, contains overall topology information, and some connection status, cost information. It will spread. So each device can be based on the information. Build up the overall topology. Then after the build is complete, We can thus know the details of the routing in the entire network. The link state protocol is calculated using the SPF algorithm. This is one of its characteristics. Then I want to ask you a few questions. How can we guarantee that this information will be synchronized? This is the first question. The second question is, what is the name of this detail? It's not the name, it's called details. In the network. Anything professional. Almost each has its own name. Then we will talk about several concepts of OSPF. For this detail, it has its own name, called LSA. After the device runs the OSPF protocol, some parameters it will produce. Of course, these parameters are not exhaustive. Let me say a few key ones at this stage. The first one is LSA. Its full name is Link State Information. It's what we call detail. Then we learn OSPF is to learn LSA. For OSPF, we will generate 6 LSAs in total. Actually, what we call LSA is very much. In our NA course, OSPF is probably taught in 1 class hour. There are about 10 class hours in the NP course. So it's actually quite complicated. But its principle is relatively simple. Now let's make some simple additions. For example, the device is now running OSPF. Then it is the same as EIGRP. It's all about declaring. There are 2 types of declaration. Also the same as EIGRP. First, declare the directly connected network segment of the device and neighbors. Lend it a neighbor. Secondly, announce some of the following network segments of the device itself. For example, R3 now declares the interface between itself and R2. Borrow a neighbor from R2. After R3 declared 3.3.3.3. This is the same as EIGRP. For example, in this, the IP address of the interface I declared. The mask of this interface I declared. The link type of this interface I declared. They are all the contents of the LSA. Include the current name of the device. Of course the generator is not R3. We'll learn something later, called router ID. This will be a router ID. That is to say, when I declare an interface, then all the information about this interface. In fact, it will be put into the LSA, and then pass the. Here is an illustration of its simplicity. So you see now this is 3 devices. We assume that there are 3 LSAs stored on each device. If there are now 30 devices, do all devices have to be synced? In the case of a large number of devices, may these routers receive so many LSAs? Where do they put this data? Just like the device is now going to 3.3.3.3 is a route. The device now goes to 23.1.1.3 is also a route. These routes need to build a table for the convenience of viewing on your own device. Whether calculating or viewing, you must sum it up. Summarize to database. That is, on each device there is now another parameter. It is also critical. This thing is called LS database. We call it LSDB. This DB is the database. LSDB stands for Link State Database. Then it is where the LSA is stored. Just like the routing table where you store your routes. The routing table stores many routes. Then a lot of LSAs are stored in the Link State Database. This is a relation